when you try to solve a physics question paper or any question paper, you just have to be careful about each and every words, and you just have to carefully read all of the things. Look at this one: an athlete accelerates. So this word is very important for us. Accelerates, and that means there is an unbalanced force due to the acceleration. Actually, without unbalanced force, this acceleration is not possible, and accelerates down a straight section of the track as shown. The track is at an angle of theta to the horizontal. They are asking to draw a free body force diagram for the sledge and athlete, and you should consider the relative sizes of the force when drawing a diagram, and be careful about the mark. This mark is 4. That means you just have to be careful about the size of the force, even direction, even the angle. All of these things you just have to consider, even all the types of force. So look at this one. In here, weight force that actually works downward direction. Okay, for this, the weight force works to the downward direction, vertically downward. And careful, it accelerates. That means there is a resultant force, so this weight will be greater, and air resistance that works, or frictional force that works opposite to the movements. Even the normal reaction, that is 90 degree or perpendicular to this. Careful. And when you draw this one, you just have to be careful about the angle and etc. Like the angle between air resistance, frictional force, and the normal reaction, it have to be 90 degree. Careful, this one should be 90 degree. This free body force diagram required a number of factors to be considered, as well as the identification of the forces acting on the sledge and athlete, the direction of each force, the correct level, and the size of this force. So be careful about this one. Most learners were able to draw the weight correctly and draw straight arrowed lines that touched given spot. The drag and normal contact force were not always at the correct angle, both in terms of their general direction and them not being at right angle to each other. They made a mistake in there, and learners should be reminded that a free body force diagram should not show component of the forces like mg sin theta and mg cos theta, and should only show forces acting on the object required. It also be noted that acceleration, velocity, and equivalent terms are not forces, and that the resultant force, or ma, is not a force to be included in a free body force diagram. The relative length of the arrow should indicate the size of the forces involved relative to one another, and the arrowed line for a weight should have been longer than both the line for the normal reaction and the friction. Careful again, like the weight should have been longer than both the line for the normal reaction and the friction.